For this code, we're going to write a code that returns elements with such of sequence adjacent elements less or equal limit. Now, I didn't write these instructions, but it seems like they're a little bit confusing. For example, though, given an array like this, and our limit is 13, we should return something like this. Now, I didn't code this to output exactly like this. The output is just going to be exactly like this. However, it's going to have everything in it but these higher values because we want everything under our limit. So what I'm going to be doing is I'm going to be taking our limit and I'm taking an integer array. And I'm going to pass these into this method right here. After I pass it into this method, we are going to go about and print the output because the new array is going to be a stored in array done. And this print method doesn't really need to be explained, it's just formatting everything. Now we can look onto the actual method. So we have our Java documentation right here, and then we have a private static integer. Because we're returning a integer array, we need these two brackets. We have our name, and then we have our parameters that we're passing in. We want our counter to get the new array length. So this is basically going to increment every single time that we have a value less than our limit so that we can keep track of it. In count, we're going to initialize it to 0. Now we want to store these values. We could, if we wanted to, use like a queue, array list, or linked list, but those can be expensive. So what I'm going to be doing is actually coding this out just straight, not using a library or anything like that. So our int counter is equal to 0. That means we have a string val, and we're setting that equal to null. Now, my thought process is that what we can do is we can take the integers from the array, we can put a space in between them and store them into a string. After this, we can use the string tokenizer class with the space as like the delimiter, and then we can put all of these into our new array. Pretty simple. So we have to make our string and declare it as null so that we can use it. Then we're going to check every value and add it to our string. Again, we could use queue or array list or linked list. If we were to do so, we could probably omit basically all of this code. Although this last code was just for testing, so we're not going to cover this, but all of this could just be gone. Probably you would need like 5 or something lines to add it to a queue. Would really just be a for loop, and you would increment your queue index and just add it in there. And then when you're done, you would just pop it out of the queue because we have first in, first out, and put this into the new array. So that's how you would do it if you were to use like a queue. If you were to use an array list, you probably wouldn't need any of this. You could just, from here, push this into that array list, and same for a linked list, you just have to convert that back to an array. So now with this here, we have our for. We're going to run this as long as our entire array because we want to analyze everything inside of here. We of course increment our a, and now in here is the heart of it. We're going to check if our element is less than our limit. If it is, that means we want to add this in. If our count is 0, we're not going to need to have a space in front of it, and we're going to need to replace this null value to our val. So what we're doing is we're going to set our val to the element here. After this, we are going to append to it a space and then our next thing until we reach the very end, every single time incrementing our count. Now, if our element is bigger, and this should also be changed, instead of array 0, that's wrong, this should be array A. If it's just array 0, it's always going to look at the 0, and it's going to put this in here every single time. So that is not what we're going to be doing. We want to change that to A. After this, I was just doing a test right here to see if it printed out. It printed out perfectly, works great. Would change this to a print because we want it all in the same line, and we're printing out our val. And our value is just a string. Now, what we're going to want to do is make a new array so that we can store everything inside of here. We're going to want to have a token to break apart our array. So we're going to have our string tokenizer, we're going to have our str equal to new string tokenizer, we have our val, and then we have a space as the delimiter. Then we want to store this into our array. So we're going to have int b is equal to 0, and we'll see what b is more in a second. I probably coded this b after inside of this while loop. So inside of this while loop, we have while our str has more tokens. This is basically like scanner has next when we're scanning something. Inside of here, I was just doing the sysout.println to test it. Keep in mind though, we can't do the sysout.println and run this at the same time, because whenever we call the next token, we're going to get that token and then it's going to take that out of the string. So it's going to basically make a substring and store that. So we can only use one at a time. So this is just for testing, and I'll put this like this. And then we have our int temp, it's equal to integer.parseInt. And then inside of here, we have our str.nextToken. So basically, because our token is str, because it is a string, remember, we're passing in our val, which was a string. So that means our string tokenizer, well, it's a string because it's a string here. So we have to do integer.parseInt to get the integer value of this next token. And since it's an integer, we can store it in temp. And then we're going to pass this temp to our new array. Now, I'm sure that we could put this inside of here. We might be able to try that later. I think I had an issue with that. I don't know if I was coding at the time, had to do a little debug, but this could possibly work. Just putting this straight into here, that omits a whole line of code. And then after this, we have our b++. And this is why I was using the b, because our int b set equal to 0. We have to increment our b every single time so that we change the index every single time. Now, we could possibly do this in like a for loop, but I chose to do it with a while loop. And then we're just going to return. So that's it for our code. That's how we would work about it. That's how it looks. And that's how we would go about solving for this question. And if you were curious about how it looks like in the Java IDE Eclipse, this is what I'm using here. And for this, we have the following. It's just the same code. We can see our comments better. We can see the code better. We can clean this up more by just getting rid of some spaces that we don't need. That's how I would do just to clean things up. Probably minimize some of these comments a little bit, maybe get rid of some of these testing. I like to include it because it can show you where, if you added more into it, the breakpoints of what you can test. I didn't mention this, and this is important to mention. This was not part of our testing. Here we're actually going to be returning our array. So we want to return our new array, and that's going to get returned here and stored in our array done, or ARR done. And that is going to be what we're printing. There's more about this and other how-to Java videos in the playlist linked below the like button.